I'm Rob Putrick, PM lead for Azure's HPC software and services platform. And at Microsoft, we are a supercomputing company. And in Azure, we've built a cloud for HPC. We have a purpose-built HPC platform that gives you the flexibility, scalability, and economics to really deliver on cloud HPC. And we connect those CPUs, GPUs, and others with fast and secure InfiniBand networking to give you the latency performance that you require. And we offer a full range of high-performance storage solutions, everything from disks to NFS to parallel file systems to blob. We are on a mission to drive a world-class end-to-end HPC experience. And we understand that doesn't just mean giving you the technical capabilities to run your workloads, but the ability to simplify cloud and simplify cloud HPC to make that transformation easier and more straightforward. And so we have workload orchestration offerings that can give you end-to-end workflow agility and meet you where you are. They enable you to use familiar tools and processes rather than force a transformation. So as part of our workload orchestration offerings, we have Azure Batch, which is a cloud-native job scheduler. This is a very simple HPC as a service model. You give us your jobs, and Azure Batch kind of understands how to dynamically orchestrate Azure's infrastructure as needed to return those results back to you. Complementary to that is Azure Cycle Cloud. This is a way of Azure enabling or cloud enabling industry standard HPC job schedulers. It's a traditional HPC scaling methodology, but in Azure. So for Batch, it has kind of two major sections, partially for the dynamic infrastructure and then the job scheduler itself. And so for Batch Pools, which manages Azure's infrastructure, it is the simplest way to deploy Azure HPC resources at scale. Configure and create VMs at any scale and easily adjust to your needs. Azure Batch Job Scheduler is an extremely scalable, full-featured, cloud-native job scheduler. Run any application unchanged across containers, Windows, Linux, etc. And Azure Batch is a developer platform. It's a way of cloud enabling your workflows, and enterprise tools such as Ansys Cloud are actually built on Azure Batch. And as such, it supports all the common languages and frameworks you'd expect. Now, Azure Cycle Cloud, more for HPC admins and others that need to create, deploy, operate, and optimize HPC clusters in Azure. It's the fastest way to get started. You can deploy a complete HPC cluster in just minutes, often with no changes to your existing architecture. And that includes built-in support for industry standard job schedulers. And as part of that, you'll get cluster auto-scaling, you'll get cost reporting and controls, authorization, authentication, and other governance capabilities. And because Azure Cycle Cloud integrates with traditional job schedulers, it actually allows you to work in both a hybrid and a cloud-native model. You can take an on-premises Slurm cluster, for example, and burst in Azure resources as needed or as your policies allow. Or you can conceptually lift and shift your on-premises environment using LSF or Grid Engine or something else into Azure and go for a cloud-native deployment, but again, without forcing any kind of transformation or re-architecture of your system. And this is capable because we focus on providing a first-class experience with the job schedulers and workflow tools and others that you use and you need. We provide leading cloud auto-scaling, and this applies for both high throughput and tightly coupled jobs. We even provide a Python module that allow you to Azure enable custom or in-house schedulers of other kinds. And more than just cores, you can do multi-dimensional orchestration. What I mean by that is, scaling based on licensing needs or data locality or I/O constraints or budget. More than just my jobs need this many cores. Cycle Cloud adds support for Grid Engine, PBS Professional, OpenPBS, and you can use any configuration, complexes, queues, you name it. IBM Spectrum LSF actually includes a production-ready Azure Cycle Cloud resource connector built right in. And as of a few versions ago, you can leverage spot VMs through LSF as well. Cycle Cloud does support Slurm, including MPI jobs and others. And as you'd expect, we have the latest operating system support that our users need. Now, in particular for Slurm, it is support for Slurm 20.11 Plus with the latest release of Cycle Cloud. And as I mentioned, that includes support for MPI jobs that require IB, as well as automatically detecting and configuring GPUs. Cycle Cloud also includes integration with Slurm's job accounting configuration and a couple other new features coming soon as well. And you can check out the official project repository there to see more details. So since we last talked at SC20, we've actually done quite a bit of improvement to the services. Now these aren't an exhaustive list by any measure. These are just the callouts and some of the highlights of the past year. But if you would like a more detailed view, you can see that in both the Azure Batch documentation and in the CycleCloud documentation. This covers all kind of the highlights as well as details of how this will affect you moving forward. And speaking of moving forward, coming soon are some more updates to our services. So in Azure Batch itself, we have improved security and reliability, specifically the no public IP nodes, which gives you complete private access to your HPC infrastructure, and a bunch of scalability improvements and other things which will drive a much better user experience. We're adding scheduling features to Azure Batch Scheduler, related to fair share, multi-instance task support, and others. CycleCloud will see core product improvements as well as deeper partnerships with ISVs and others. And similar on the HPC and AI support side, we're also driving partnerships with key ISVs. And the thing there is we recognize that HPC environments are complex, and they are a kind of conglomeration or aggregation of different technologies. Some of them Microsoft, some of them open source, in-house, third-party, legacy, you name it. And we really only can provide a comprehensive orchestration experience in the cloud, as well as a simple and comprehensive support experience if we work on integrating those technologies together. And alongside that, we'll have ongoing portal and process improvements to provide a better support experience. So Azure HPC does provide worldwide 24/7 HPC AI support. And this is a team of genuine HPC experts and dedicated to these issues. And their mission is to work with customers to solve your HPC and AI needs. And again, they understand that these environments contain multiple technologies working in concert, often heavily optimized to get you the results that you need. And you can see how this fits back into our overall mission to drive innovation and leadership of the HPC and AI cloud customer experience. So if you'd like to learn more, you can find more about Azure HPC in general on the Azure website. There's also a bunch of free training modules at MS Learn that you can find at aka.ms/HPClearn. You can look at industry-specific solutions, as well as engage a partner to help implement high-performance solution. Thank you very much.
Hello, my name is Evan Burness, and today I'll be talking to you about Azure HPC virtual machines. In Azure, the H-Series product portfolio of virtual machines features two product families, the HB series featuring AMD EPYC processors and the HC series featuring Intel Xeon processors. Both HB and HC series virtual machines feature InfiniBand networking technology. Azure's use of InfiniBand differentiates it among the public cloud providers and features a full non-blocking factory topology, hardware offload of MPI collectives for optimal MPI workload performance, high bandwidth HDR InfiniBand 200 gigabit per second interconnects, and support for bare metal pass-through of the InfiniBand NIC, meaning customers can use standard OFED drivers. In Azure, we provide our customers a continuous stream of improvements to their HPC workloads. In 2019, we introduced our first HC series. In 2020, we became the first public cloud provider to not only introduce AMD Rome processors for high-performance computing use cases, but also to pair it with one of the world's first installations of 200 gigabit HDR InfiniBand networking. Finally, this year in 2021, we became the first cloud provider or bare metal provider to debut on the launch date of the AMD Milan processor with full support in Azure on an HPC product line in our HBV3 virtual machines. As we look across the public cloud, we can see that Azure's focused design intent on HPC workloads rather than on a broad swath of general purpose workloads, positions Azure to offer a highly differentiated level of virtual machine performance. Here, when looking at the industry standard spec rate floating point CPU 2017 benchmark, which tests 14 real-world scientific computing applications across 13 engineering and scientific domains, we see that Azure delivers nearly a 3x uplift over many public cloud provider alternatives. As we look to multi-node performance, the story gets even better. Using the widely used OpenFOAM application and using publicly available reference data from a competing cloud provider, we can see that Azure HBV2 virtual machines featuring powerful AMD Rome CPUs and 200 gigabit InfiniBand networking not only provide substantially higher performance than the leading HPC product from a competing public cloud provider, but that level of performance differentiation actually rises with scale. Perhaps more impressively, Azure costs less to run this workload at any level of scale. So not only do customers get faster performance, they get lower costs as well. As we look to extreme scale performance, a hallmark of the high-performance computing community, we can see that across a broad range of applications, Azure offers a decidedly large advantage in scalable performance, extending 12 times as high as the next closest public cloud provider. Azure's ability to scale workloads isn't just good compared to other public cloud providers. It's very good compared to even some of the world's leading supercomputers. Here, you can find benchmark data comparing Azure HBV2 virtual machines against the Frontera supercomputer at the Texas Advanced Computing Center, which currently stands as the U.S. National Science Foundation's Track 1 supercomputer and ranks among the top 10 supercomputers globally. On NAMD, one of the most widely used molecular dynamics applications, and scaled up to 512 servers and more than 60,000 processor cores, Azure HBV2 virtual machines provide a 40 to 90% performance advantage over the TAC supercomputer. Finally, at Supercomputing 2021, we're excited to announce that AMD EPYC Milan-X processors are coming soon to Azure HBV3 virtual machines. Milan-X processors increase effective memory bandwidth by up to 50%, while decreasing effective memory latency by up to 66%. No technical changes are required by our customers, and the exact same HBV3 virtual machine sizes that they know and already use for their production and research workloads will persist. Customers can also sign up for a private preview now. Thank you for joining me, and we hope to see you on Microsoft Azure, the world's supercomputer.
Hi, my name is Sherry Wang, Senior Program Manager for Azure HPC and AI Platform team. Today I'm going to talk to you about our N-series virtual machines for AI and visualization computing at every scale in Microsoft Azure. Azure GPU products have 3 product lines that are optimized for distinctive workloads. The NV series have been optimized for GPU power visualization workloads, such as CAD, gaming, and simulation. The NC series are designed for general compute workloads with flexible sizes for lightweight and mid-range AI, analytics, simulation, and rendering. The ND series are designed for a scalable deep learning workload that requires scale-up and out multi-GPU VMs for dense AI computing. Our NV sets family are targeted for GPU-accelerated graphics applications and virtual desktops, where customers want to visualize their data, simulate results to view, work on CAD, or render the stream content. Additionally, these virtual machines can run single precision workloads, such as encoding and rendering. The latest offering from NV series is NVV4, which is based on the AMD Random Instinct MI25 GPU and is specifically designed to provide you unprecedented GPU resourcing flexibility. You can now choose VMs with a whole GPU all the way down to 1/8 of a GPU. This makes entry-level and low-intensity GPU workloads more cost-effective than ever before, while still giving customers the options to scale up to powerful full GPU processing power. I'll be covering how we in Azure think about and design for our AI customers. Throughout the past few years, Azure continues delivering high-quality VMs to accelerate AI workloads. Light compute VMs to lower the cost of hosting AI service when you need them, where you need them, with a light compute-oriented GPU instance. The mid-range VMs offers versatile throughput-oriented options for batch inferencing, analytics, and demanding business workloads. High-ambition VMs let customers with ambitious AI training requirements scale up without slowing down, featuring the industry's fastest GPU networking. We have customers rolling out multi-region inferencing-based service that need to hit new price points to be able to appeal wide user base. We, at the same time, having customers to pushing the envelope of what natural language AI can do, and for them, training the billion parameter plus model is routine. The gamut between a real-time inferencing requirement, where you need a lot of small GPUs and a wide worldwide footprint, to the effective use of a GPU supercomputer to train the large-scale models. And we're proud to have a portfolio that has kept pace with these requirements. We're deploying new capacity on newer GPUs from 1 T4 all the way to thousands of 800s. The latest offering from NC series is NC-T4 V3. It features 4 NVIDIA T4 GPUs with 16 GB of memory each, up to 64 non-multi-threaded AMD EPYC process cores, and over 400 GB of system memory. These virtual machines are ideal to run ML and AI workloads utilizing CUDA, TensorFlow, PyTorch, Caffe, and other frameworks, or the graphics workload using NVIDIA-grade technologies. Back to this June, we launched ND800 V4 series that featuring NVIDIA 800 Tensor Core GPUs, each equipped with 40 GB of HBM2 memory. It's a massive supercomputing deployment in the cloud, geared at deep learning training and tightly coupled accelerated HPC workloads. This is expanding Azure leadership class AI supercomputing scalability in the public cloud. I am proud to share that our Azure ND800 V4 VMs claiming 4 official places in top 500 supercomputer list. This milestone was thanks to a class-leading design with NVIDIA Quantum InfiniBand networking, featuring in-networking computing 200 GB per second and GPU Direct RDMA for each GPU, and an all-new PCIe Gen 4 based architect. After we launched ND800 V4 for a few months, we see increasing demand for large-scale AI model training. To fulfill customers' needs, we decided to offer a new series with high memory solution. This brings us to the NDM800 V4 series that doubles GPU memory to 80 GB, along with a 30% increase in GPU memory bandwidth for today's most data-intensive workloads. RAM available to the virtual machines has also increased to 1900 GB per VM to allow customers with large datasets and models a proportional increase in cache space to support novel data management techniques, faster checkpoints, and more. The high-memory NDM800 V4 series brings AI supercompute power to the masses by creating opportunities for all businesses to use it as a competitive advantage. Cutting-edge AI customers are already using both 40 GB and 80 GB ND and NDM 800v4 VMs at scale for large-scale production AI and ML workloads to power their AI ambitions, needs, and see impressive performance and scalability, such as comprehensive AI-powered voice-enabled solution, large-scale cognitive science model training, and many more. With this high memory solution, customer can gain up to 50% performance improvement without changing their workloads. The new high memory NDM800v4 for data-intensive GPU compute workloads reaffirms the Microsoft commitment to rapidly adopting and shipping the latest scale-up and scale-out GPU accelerator technologies to the public cloud. Azure helps you taking from world's computer towards supercomputer. Thank you.
Hello, my name is Scott Jashonik, Principal Program Manager with Azure Storage, and I'm going to share some of the HPC storage choices available to you in Azure. To start, I'd like to review storage considerations when deploying HPC solutions. Although the main goal is really to saturate the CPUs and GPUs of each compute node in your HPC cluster, there really are several other dimensions of storage access that may be required or considered. For example, you'll need to consider storage requirements for your scheduler, information such as your logs and your queues. You might use a VM with attached disks for this purpose, or you might consider a database service or roll your own database, MySQL database. At smaller, this really may not be a huge requirement, but if you're running a larger cluster and you're running a lot of concurrent jobs, this may become a bottleneck for you. You also may need to ensure your libraries and toolchains are accessed quickly by the compute nodes. One way to do that might be to copy the toolchain information to the local disks on the machines. This is especially a concern if you start to run a large number of HPC cluster nodes and the start times are dependent on the access of those libraries and toolchains. Another way you might have to optimize is use shared storage for those tools or tool chains to, some sort of scaled out NAS solution, for example. This method may be more useful at larger scales. You may have scratch space or checkpointing requirements. That means not only does your read performance have to be optimized, but you also have to ensure that there is sufficient write performance to not create any bottlenecks in the workload's throughput. And finally, being able to write out the results. You can still write data back to your on-premise storage environment if necessary, or you might use something like a blob or an NFS solution in Azure. Ultimately, you might want to consider putting all of that data into a tiered data lake that can then be consumed downstream by other services beyond your HPC cluster, such as Azure ML or other analytic tools. And so putting all of your data into blob might be of interest, and we'll talk about that a little bit in the next couple slides. Here we have the overall Azure cloud storage vision. The vision diagram doesn't explicitly show disks, but disks are definitely there. Azure offers multiple managed disk solutions ranging from HDDs to something we call Ultra SSD managed disks that allow you to co-locate your data beside your VMs and containers. And those disks obviously have different price and performance metrics, the HDDs being the cheapest and then the Ultra SSDs being the most expensive but the highest performant. But what you see in this diagram is a multi-tiered storage stack that has all the resiliency, redundancy, compliance, and security that you would expect from a world-class, globally distributed storage solution. It has automatic lifecycle management and an ability to provide movement of the data between different performance and pricing tiers. On the right side of the diagram, you can see products and services which you can use to ingest the data from your on-premise environment into the storage stack. Depending on what you're doing, maybe you're an autonomous vehicle vendor and you want to upload the car information into Azure, you can use some of these tools to do that. Of particular interest in this diagram is the red area above the tiers, and more on that in the next slide. One of the key aspects of this vision, which is available today, is something that we call Azure Data Lake Storage. Azure's implemented a hierarchical namespace on top of the object storage solution. It's just a feature of object storage environment. You just enable it. By enabling the data lake, you open the door to having multiple protocol access of the underlying blob storage, whether you're using the Blob API to make calls, or if you wanted to run a Hadoop or a Spark environment against some of the data in object storage, but you wanted to use a HDFS file system, you're able to enable that on top of your Blob object storage. Also part of Azure Data Lake, and something that's in preview now that's soon to be GA, is our NFS v3 endpoint. And these protocol endpoints are really a unique value that Azure brings to the table with their entire object storage solution. And that object storage solution is ultimately a singular, deep, geographic, dispersed lifecycle managed solution, and it's fronted by multiple protocols. We also have a series of file system offerings that complements the overall storage vision. One of the main partners in this is Cray Compute, which offer their best-in-class Lustre file system called ClusterStor to customers in need of very high-performance, large-scale parallel file systems. ClusterStor is a bare metal offering that is placed directly into Azure data centers. This table gives you a breakdown of the three main offerings. ClusterStor can provide anywhere from 5 petabytes to 45 petabytes of storage. And it's important to note that these Lustre systems are built on demand. These are bare metal systems that are deployed into Azure data centers based on your needs. Consistent with our single stack storage vision, we have an HSM solution that allows you to store the large portion of your data in a lower cost blob and only transfer the working data into the Lustre systems as you need it. We also have Azure NetApp Files, which is NetApp's actual hardware and software solution deployed in Azure. They put NetApp services in Azure on actual hardware, and they provide multiple tiers of performance and multiple file protocol access. Azure NetApp Files supports NFS v3 and 4.1 and also SMB3. And you can use ANF not only for HPC workloads, but also for general purpose NAS use cases, including hosting databases or file sharing. This slide gives you an idea of the pricing and performance tiers. ANF offers pools volumes at standard, premium, and ultra, and you have the ability to move between these tiers of performance, as well as being able to move the size of the volumes up and down dynamically. ANF supports provision throughput up to 4.5 gigabytes per second, and the max volume size is 100 tibibytes today. Now, obviously, you can have multiple volumes, and there's ways that you can bring those volumes together, and let's talk about one of those ways next. HPC cache is a file system cache that lives adjacent to your compute or container workloads and allows you to create a pseudo file system that points to the storage. Whether it's sitting in your existing data center NAS solution, such as isolate other system, maybe it's sitting in an ANF volume and you need it to geographically access volumes from other regions without syncing the data. Or maybe you want to build a cloud NAS out of multiple ANF volumes, or potentially a blob container, or all of the above. This is the service that you can use to do that. A great example of how you might use this is if you want to try an HPC workload in Azure and you're not yet at the point where you're moving all of your data into the cloud, or you don't want to move all your data in the cloud. Running HPC cache will give you the ability to stand up a transient cache, access the data when it's done being processed, delete that cache, and the data is gone from Azure. And this is something you can use for that. This slide gives you an idea of the architecture. HPC cache sits in front of, sits in your Azure subscription and can access your storage, whether it's across an express route or in a different region. You can also bind together multiple on-prem systems or cloud systems, or both, into a single directory structure, and then serve that up to your HPC compute cluster. And these are the different HPC cache SKUs, ranging from 2 gigabytes per second in throughput up to 8 gigabytes per second. With various sizes of cache disks, depending on what your working set is. And with that, I wanted to thank you very much for your time. Please check out all the Azure storage solutions at azure.com.